This is my PhD in chemistry, and this is an intro to the key functional groups that form the basis of organic chemistry. Due to carbon's ability to form 4 bonds, which can be single, double, or triple, many different structures can be constructed. The simplest types of hydrocarbons, CH only, are called alkane, and consist of only a single bond between the carbon atoms or the carbon-hydrogen atoms. They follow the general formula C sub n H sub 2n plus 2. Where n equals the number of carbons. Examples include methane, where there's 1 carbon, and 1 times 2 plus 2 equals 4 to get the formula CH4, and butane, 4 times 2 equals 8 plus 2 equals 10. The next are alkenes, that contain at least 1 double bond between the carbon atoms, with the general formula CnH2n. An example is ethene, with the molecular formula C2H4. Last are alkynes, which contain at least 1 triple bond, with the general formula CnH2n minus 2. An example is ethyne, also known as acetylene. A good way to remember this is with the A, E, Y is alphabetical for the hydrocarbons, just like 1, 2, 3 is numerical for the bonds. Other than alkanes, alkenes, and alkynes, here are the most common functional groups you'll see in organic chemistry. First is the hydroxyl group. The hydroxyl group, aka an alcohol group, consists of an oxygen atom bonded to a hydrogen atom, where this OH gets its name from. Compounds with the hydroxyl group are called alcohols, with the most infamous being ethanol, which is consumed as alcohol across the world in beers, liquors, whiskeys, vodkas, etc. The presence of a hydroxyl group increases the solubility in water and affects the boiling and melting points of the compounds due to hydrogen bonding and other dipole-dipole interactions. Ethers. Ethers contain an oxygen atom connected by 2 alkyl or aryl groups, R, O, R', where R and R' can be the same or different carbon-containing molecule. Ethers are relatively inert and have low reactivity compared to alcohol. They are generally less polar than alcohols, making them good solvents for a wide range of organic reactions. Ethers have a lower boiling point than alcohols of similar molecular weight due to the lack of hydrogen bonding between the ether molecules. Diethyl ether, most commonly known as just ether, was historically used as an anesthetic. Next is the amine or amino group, N, R sub 2, or NH sub 2. You can also have an NRH. The sub 2 means that there's 2 groups, whether that's 2 hydrogens or 2 R groups. Not to be confused with our superscript 1 or prime. Compounds with amino groups are called amines, and they can act as bases, meaning that they can accept a proton. Nitrile. Nitriles contain a carbon atom triple bonded to a nitrogen atom. The general formula for a nitrile is RC triple bond N, where R is an alkyl or aryl group. Nitriles are polar due to the electronegativity difference between the carbon and nitrogen atom, leading to a dipole moment. They have higher boiling points compared to alkanes of similar molecular weight due to the polar nature of the nitrile group. Nitriles can participate in a variety of chemical reactions, including hydrolysis to form carboxylic acids and reduction to form amines. One example of a nitrile is acetonitrile, CH3C, which is a common solvent in the laboratory. Halides, RX. Halides are organic compounds in which one or more of the hydrogen atoms in an alkane or other hydrocarbon has been replaced by a halogen atom, such as fluorine, chlorine, bromine, or iodine. The general formula is RX, where R is an alkyl group and X is a halogen. Alkyl halides, also known as haloalkanes, are halides where the halogen is attached to an aliphatic carbon chain. Aryl halides, also known as haloarenes, are halides where the halogen is attached to an aromatic ring. Next is the carbonyl group, C double bond O. Carbonyl group consists of a carbon atom double bonded to an oxygen atom. This group is found in several types of organic compounds, including aldehydes, ketones, esters, amides, anhydrides, and carboxylic acid. Aldehydes are CHO. Aldehydes contain a carbonyl group with the carbon atom also bonded to a hydrogen atom and an alkyl or aryl group. The general formula is RCHO, and they're typically more reactive than ketones due to the presence of the hydrogen atom attached. Formaldehyde is the simplest aldehyde and is used in the production of resins and disinfectants. Ketones are CO, R'. Ketones contain a carbonyl group, C double bond O, with the carbon atom bonded to 2 alkyl or aryl groups and are generally less reactive than aldehydes. Acetone is the simplest ketone and is widely used as a solvent, such as in nail polish remover. Esters are next, with the general formula RCOO R'. Esters contain a carbonyl group, C double bond O, adjacent to an ether linkage, OR. They are less polar than carboxylic acids and alcohols, making them good solvents for organic reactions, with the most common being ethyl acetate. Next are anhydrides. They're organic compounds derived from two carboxylic acid molecules by the loss of one water molecule, hence the name anhydride, meaning without water. The functional group of an anhydride is characterized by two acyl groups, the RC double bond O, bonded to the same oxygen atom, with the general formula being RCO2O. Anhydrides are quite reactive, especially compared to their parent carboxylic acids, due to the presence of the electron withdrawing carbonyl group on either side of the oxygen, which makes the carbonyl carbon more electrophilic, which means loves electrons. Acetic anhydride, seen here, is a common anhydride used in the acylation reactions. Acylation is just a transfer of this group here. Next up is the carboxylic acid, which we've talked about pretty extensively before, with the general formula COOH. COOH. They contain a carbonyl group, C double bond O, and a hydroxyl group, OH, attached to the same carbon atom. The general formula RCOOH is also called a carboxyl group. Carboxylic acids are typically polar and can form hydrogen bonds, resulting in high boiling points. They are also weak acids and can donate a proton in aqueous solutions. The most basic carboxylic acid is acetic acid, which is used as a solvent and is found in vinegar. Last but not least are amides, RCONR2. The general formula is RCONH2, where both of these are hydrogens, RCONHR, where one of these is a hydrogen and another one is an R group, or RCONR2 seen here. Amides are typically polar and can form hydrogen bonds, leading to higher boiling points. NN-dimethylformamide is a common solvent used in organic synthesis.